Hi everybody, I'm Shannon Kirk. I'm a student at the University of Georgia, and I'm happy to share some of the preliminary results from my research looking at different biofouling mitigation methods in the southeastern Atlantic. So I'm sure many of you are familiar with the floating cage systems, the Oyster Grow 6-bag floating cage systems, and the benefits that can come from using these cages. Not only are the oysters suspended in that nutrient-rich water column, but they're off the ground, they have reduced risk of predation, and it's easier for growers to access their oysters. On top of that, it's also a really good place to provide habitat for reef-dependent species, but because of this reef-dependent species habitat, it also brings up the issues of biofouling or dirtying of gear. So biofouling is an accumulation of any organisms on gear that are undesirable, and it's typically split into two different categories of soft fouling, which are algae and soft-bodied tunicates, which are relatively easy to clean off. But then there's also hard fouling of barnacles and spad and mussels. That's a lot harder to clean off and can cause damage to gear when you're trying to clean that off. And when it's mild, like I'm showing you here, it's not a massive problem, but when it starts to get really bad, it can actually reduce the amount of flow that gets to the oysters and can impede their feeding and cause issues with competition. So for my research, I wanted to look at two different biofouling mitigation methods. The first was aerial drying, which is a popular method that's used, and typically the gear and the oysters are kept exposed for about 24 hours in the air, and it kind of acts as an extended low tide that stresses those smaller organisms that are trying to attach. The second method that I was looking at was a fouling release coating. Specifically, mine was called Netminder, and it is a non-toxic water-based silicone release coating that may reduce the adhesion rates of these fouling organisms on the gear. So for my project objectives, I really wanted to determine the effects of drying frequency and the fouling release coating on a number of things. First, the biofouling on the grow-out gear and the biofouling on the cultured oysters themselves. But of course, I wanted to keep in mind that oyster quality and oyster growth, or how long it takes for those oysters to get to harvest, are also important factors that I need to keep in mind. I had oysters in 3 different study areas. The first was in Wausau Sound in Georgia, and those oysters were managed by the University of Georgia Shellfish Lab. The second was in St. Helena Sound in South Carolina, and those oysters were managed by Ladies Island Oyster. And finally, in North Carolina, my oysters were in Core Sound and being managed by Carolina Mariculture Company. So to get a little bit into the experimental design, I wanted to look at 3 different biofouling drying frequencies. And the first was flipping the oysters for 24 hours every week, which I'll call weekly, every 2 weeks, which I'll call biweekly, and every 3 weeks, or tri-weekly. We had 6-bag cages, and 50% of the bags in those cages were coated with that Netminder coating, and we made sure to put them in a Latin square design to try to make sure that bag placement was not a factor in our results. So to kind of bring this all down into one nice pretty table, at each site we looked at 3 different drying regimes, and there were 4 cages in each drying regime, resulting in 12 cages at each site. There are 6 bags in each cage, so 72 bags at each site. Half of those bags were treated with Netminder, so 36 bags per Netminder treatment, and 36 bags without the treatment. And we loaded those bags with 150 oysters, meaning 10,800 oysters at each site. To collect data, we did quarterly measurements. So we went out and looked at shell height, length, and width to try and determine how these oysters were growing. We also harvested oysters in June and October and took 10 oysters from each bag. We froze those oysters to later look at those same shell metrics to shuck them to determine condition of the meat inside, as well as to determine the hard, soft, and total fouling coverage of those oysters. Of course, we wanted to look at gear fouling as well, so we photographed our bags every time we went out and measured the oysters. That allowed us to do a visual analysis of the fouling in its progression at each monthly or quarterly interval by taking a subset of that photograph. And we noted common fouling organisms from barnacles and oysters to bryozoans. And at the end of our harvest, in October, we emptied the bags and weighed them as well to see how much fouling had accumulated on those bags. So a little stats in the morning is always great. I'm using a split plot design, which is used a lot in agriculture, which essentially means that I'm looking at the whole unit factor first, which is that aerial drying regime, and then I'm looking at the bag coating because that is nested within those cages. I'm using linear mixed effect models and using R as my platform and doing 2-factor ANOVAs with Tukey's post hoc test and a alpha value of 0.05. I hope I didn't lose you too much. Here's some pretty graphs. First I want to look at Georgia shell height. So at the bottom, or on the x-axis here, I'm always going to have weekly, followed by biweekly, followed by triweekly. The lighter bars, or the bars on your left, are going to be the coated bags, and the darker bars are the not coated bags. The black line that's running across this is the starting average shell height of 30.9, which was what the oysters were when they first went out, so you can kind of see how much they grew. And on the y-axis here, I have shell height. So when we first looked at the oysters in December, they were deployed in September. So when we looked at them in December, you notice that the not coated bags actually had a higher shell height than the coated bags, and the weekly treatment oysters had a lower shell height statistically than the biweekly and triweekly oysters. But as we continue on to March, with our next sampling period, that weekly lower shell height continued as a trend, but the bag coating was no longer a trend anymore. And finally, at our last sampling that I have to present today in June, the tri-weekly and the weekly bags were different, but they were not different from the bi-weekly bags. So the weekly bags were still lower, and we still see no difference with the bag coatings. And forgot to mention, those error bars are standard error for people who want to know what the error bars are representing, because it could be a number of things. Moving to South Carolina, the first sampling period, there was no difference between any of the aerial drying frequencies or the bag coatings. We saw a little bit of a difference in the bag coating, with the not coated bags being having a higher shell height, and the tri-weekly flipped bags being with a higher shell height. But then in our last sampling period, that kind of equaled out with the biweekly bags, and the weekly bags again had a lower shell height. With North Carolina, same story with the beginning, but surprisingly biweekly came and took over having the highest shell height in the March sampling period. But then by June, again, that weekly bag kind of ended up being the lower performer. And so to bring this all down to one month of final shell height data for June, in Georgia, the weekly and tri-weekly bags were different, with weekly being lower, but not too different from the bi-weekly bags. The weekly bags were the lower performer in South Carolina, and then the weekly bags were the lower performer in North Carolina as well. Moving on now to cup ratio. The cup ratio is on the y-axis, and again, it's now going to, instead of over time, it's going to go by state, with Georgia, South Carolina, and North Carolina on the x-axis, but the same arrangement and the same color scheme for my other treatments. The weekly bags had a higher cup ratio, and that's the same in South Carolina, seeing a higher cup ratio with the South Carolina bags. But in North Carolina, there wasn't a difference between the flipping regimes, but the coated bags had a higher cup ratio than the not coated bags. Looking at oyster condition, I only have South Carolina and Georgia to show you today, but and I'm not comparing the states, I'm just comparing within each state. There was no difference with any of the flipping regimes for condition, so all of the condition was equal across all of my treatments for the weekly and the coating and not coating. In terms of oyster fouling, so I translated this to essentially be grams of oyster fouling per a 3-inch oyster. I took the average weight of a 3-inch oyster, which would be at harvest, and translated that to how much fouling would be on that oyster. And again, there's no difference with our flipping regimes with Georgia or with South Carolina. But there's a big difference when it comes to bag fouling. So if you look at percent coverage on the y-axis for bag fouling, the Georgia tri-weekly bags were significantly more fouled than the weekly and bi-weekly bags. In South Carolina, there was no difference with the flipping regimes or the coating, and surprisingly, the weekly bags actually had a higher bag percent coverage, but overall, that's a pretty low percent coverage for the amount of fouling on a bag. So for my preliminary conclusions, the fouling release coating at the end at harvest point in June didn't really make a difference. In terms of the aerial drying treatment, we did see some results where the biofouling on the grow out gear, there was more fouling on the gear in the tri-weekly treatments in Georgia and in the weekly treatments in North Carolina. But the North Carolina treatments still had a very low amount of fouling on them. In terms of fouling on the oysters and oyster quality, there was no effect on condition or the amount of oyster fouling. But there were higher cup ratios on the weekly treatments for at least Georgia and South Carolina. And in terms of oyster growth, we saw a consistent result of a slower growth with the weekly treatment oysters. And for my next steps, I want to look at the economics of this whole process. I have October data that I want to look at because these oysters that look so pretty and clean at the June point then turn into these big, very, very fouled monster reef balls that are very fun to clean, I promise you. And then I still have North Carolina data that I need to get through, and then there's a Gulf study that's also going on that Chappie's going to talk about after me to look at the results from that. And I would like to thank all of the people who have helped me with my research, all of the people who have helped me shuck oysters, because I have shucked a lot of oysters, the SRAC for funding my research, and the Warnell School for giving me the ability to learn about all those lovely statistics that I told you about earlier. And I am happy to take any questions if you have any.
Any questions for Shannon?
It was a wet weight of the biofouling, so I scraped the fouling off of the oysters and I separated them from hard fouling to large soft fouling organisms. So I taking barnacles and spat into one category and then taking sea grapes into another category. And then after I clean them, then that gives me an idea of how much algae is on there. I would definitely look at the drying treatment. That's the variable that really made a difference in all three states. So it would be it would be different in each state, but that's what I saw the biggest effect on biofouling was coming from that drying treatment effect. It could have been that. I didn't do any kind of histology on those oysters, but it could have been that the coating was coming off. But other than that, I don't really have a known effect for that.
Thank you, Shannon. Appreciate it.